Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today, for exam P on probability. An American male 100 meters runner is preparing for the 2012 Olympic Games. After repeated runs, he determines that his 100 meters sprint run time is normally distributed with mean 9.88 seconds and standard deviation sigma. He has been also observing his Russian competitor and determined that the Russian's sprint time is normally distributed with mean 9.99 seconds and the same standard deviation sigma. Given that the probability that the American beats the Russian is 0.9015 and that their sprint times are independent, determine sigma. And here's the solution. So let us write x for the sprint time of the American athlete and y for the sprint time of the Russian sprinter. Then x is normal with mean 9.88 and variance sigma squared. Y is normal with mean 9.99 and variance sigma squared. And y minus x is normal with mean 0.11 and variance 2 sigma squared because they're independent. So it's a difference, but we just add variances because minus x has the same variance as x. Therefore, if we write z for a standard normal random variable, we have probability that y is more than x is probability that y minus x is more than 0, which is the probability of y minus x minus 0.11 over sigma square roots of 2. Sigma square roots of 2 is the standard deviation of the difference, is greater than minus 0.11 over sigma square roots of 2, but y minus x minus 0.11 over sigma square roots of 2 is standard normal because y minus x is normal with mean 0.11 and variance 2 sigma squared, so standard deviation square root of 2 times sigma. So this is the probability that a standard normal random variable is greater than minus 0.11 over sigma square roots of 2, and we know that this is equal to 0.9015. Well, from the table, we can look up that minus 0.11 over sigma square roots of 2 has to be equal to minus 1.29 for the probability that z is greater than that number being 0.9015. So that from this, now this is just an equation with sigma as the unknown, we get sigma to be 0.11 times 1.29 times square root of 2 to the negative 1, so 1 over 1.29 times square root of 2. And that's approximately 0.0603, which is answer D. Please remember, this is copyrighted material. The problem comes from me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.